All right, so I'm going to kind of continue from last time, right? Continuing from trends. So kind of reviewing some parts. I realized I don't remember, did I show you guys this picture last time and go over this? I think I skipped over this by accident.
Yeah, I
Does
don't
this
remember it, but I
Yeah,
could be
okay.
wrong.
Okay, cool. The curriculum has something very similar to this right here. This is actually from this blog right here, which is again in that link. But just kind of mentioning it is that the stationary versus non-stationary. So you can see basically is our stationary series shouldn't have like really any dependence in time. It's not changing right through time essentially. So you can think of it like the mean is not a function of time. So the average is not changing over time. We don't have an upward trend, an exponential trend, linear trend, right? The variance is not a function of time. So this is like heteroscedasticity, right? So right now that everything's spaced perfectly each time, but you can see here in this case, as time goes on, the variance changes where we have essentially it going larger or smaller. So kind of like heteroscedastic, right? And then the last part is our covariance, which our covariance is kind of a tough one to kind of like, I think it's hard to wrap your mind around for a second, but you can kind of think like it depends on what it was previously. So this essentially has like more of an accordion kind of effect, where essentially things become more frequent like at certain times. So you might have kind of like this kind of squishing going through where its period is no longer regular. It's kind of like, oh, it's basically getting squished across. So essentially our stationary trend should not have any of this. The mean is not a function of time, the variance is not a function of time, and the covariance is not a function of time. That's why we call it stationary, meaning it's not changing over time. Okay, cool. Sound good, everyone? All right, so I wanted to read that because I realized I skipped over it. And then this just shows like no trend in general. Like the thing is like it's tough, like, oh, is there a trend in here? This way you can do decomposition, which we'll get to later today. But just kind of reiterating, just remember like there's upward trends, like linear trends, right, downward. We also have an exponential trend in this case. You can see it going up. It starts off looking linear, but then eventually takes off. That's kind of the key part of like seeing it's exponential. We have periodic trends, right? So this, for example, might be something like the temperature right over the year, which we would expect it to fluctuate with a kind of regular interval, like when that would be. Note that there's still some staticky kind of mess in here, but you can definitely see there's a general trend of up and down. And you can see here miles flown, I think it's from the curriculum as well, by year, and that there is kind of like some seasonality to the number of miles flown, right? Maybe people fly during the holidays more and stuff like that. But there definitely seems to be something else here as well. Like, for example, you might see, well, it seems to be going up and then seems to flatline. And maybe, for example, like maybe there's something with the actual size of those fluctuations. Like maybe that's an adjustment too. So this might have some extra trend beyond just it being periodic. Okay. So again, kind of continuing from last time, we assessed our trends. We said, okay, we took this guy right here, which is our New York Stock Exchange, which sees an exponential trend. We looked at rolling statistics. So basically we have that little window that moves along on our time series. And this red line represents basically it averaging over, in this case, looks like 8 different points and averaging across. Note that you don't want to average too large. If I averaged over like 10 or 12 or 8 might even be arguably too large, is that we'll start losing this information. And you can kind of tell this is that right here, it seems like, okay, it seems to be traveling more or less in the middle of this, a set. But once I get closer to where the exponential part is, right, like the really exponential, you can see it underperforms. And that means we're losing some of that information because remember, it's doing an average. So the average is not as robust against larger values. So it's going to, those smaller values are going to pull it downward. And that's why you essentially see it underperform underneath here. And that's not really what you'd want. You'd probably want something closer to like, let's say put like 4 here. You might see something like this, which is a little bit more accurate of what's going on. It still might have a hard time catching all of those parts because you are averaging, but this seems to kind of catch a little bit more of like the reality. And of course, having a window, I think we showed, if we showed like a window of 1, you can see basically that is averaging over each point. So there's no difference. Okay, cool. All right, so, and then the last part we showed was dickey-fuller. Basically the dickey-fuller test shows statistical test to see, is this trend stationary, right? So we want basically to reject a null hypothesis, say, okay, like, does this thing actually, is it stationary or is it not? So there's some more information too on this resource for stats models. But the main idea here is we're basically testing to see, hey, is this actually stationary or not? Okay. Cool. All right, so that's kind of where we left off last time. That was kind of a quick, like, 4-minute review. Now we can talk about, okay, we see how different trends. We can look for, it being stationary. Let's try removing trends.